Thank you, Greg, for the kind introduction, and thank you, Abba and Billy, for hosting us here. And I'm very happy to be here among colleagues and friends that I've known for decades. And I thank you all for coming in this great weather that we have here. The presentation that I'm going to give today was tailored for this occasion as basically a tasting menu, because I can't go over all this information that's in the report. So it's basically to get you interested in reading some more when you go back home, and you can look at the report. This work, of course, was not done only by me. One of my colleagues, Alex Bly, is here today. Others couldn't make it. As I said, this was supported, as Greg said, it was supported by the World Bank, the NSF, NASA, Cities Alliance, and the Institute. And I want to thank everybody, and especially also Eduardo Rojas, for coming to give this the comments on the story. Now, I will go through the outline of the paper rather quickly, and I want to start with a story that will give you the framework for this. I spent many years in Bangkok, and 10 of which I was a professor at the university. And at one point, I was the chairman of the campus planning committee. And the USAID was going to give the university a big mainframe computer, and I was doing research to figure out where to put the computer center. And the president wanted the computer center right at the entrance for everybody to see it when they come in. So I came to talk to him, and I said, I did the analysis on where the best place to put the computer center is, and it's at the center of the campus. And the president said to me, "Don't confuse me with data, Solly. I've already made up my mind." So this analysis, to follow what Abba was saying, is an analysis that tries to look at the data and urges you to look at the data before you make up your mind. And unfortunately, most people have already made up their mind. So it's getting difficult. Most people have already decided for themselves and have been indoctrinated over the last, a couple of decades, that cities must be contained. And the containment paradigm is what drives city planning today. Namely, cities should not be allowed to expand. They take up too much land, valuable agricultural land. Because of that, we have sprawl. Because of sprawl, we have pollution. Because of sprawl, we have obesity. That's the latest. Because of sprawl, we have energy loss. We need to contain cities, make them denser, fill them all up. And these are some of the most important examples of containment. London, Seoul, and Portland, the best American example, the Portland urban growth boundary. And this whole thing questions the issue of containment. And the simple question has to do with, okay, let's look at how fast cities have expanded. So we looked at 30 cities, a representative sample of 30 cities during the last 200 years. And we found that on average, 28 out of these 30 cities increased the area 16-fold during the 20th century. So when you look at this graph, you see, let's say, Mexico City starts out with about 1905 with 1/16 of its population in 2000. And that's the same for all of these cities. So you ask yourself, if cities increase their area 16-fold, where are we going to contain them exactly? So we can talk about containment in Portland, which is still expected to maybe have 1 million people in the next 20 or 30 years. But when you start talking about the 340 Indian cities that have more than 100,000 people, then you ask yourself, where exactly are we going to contain them? Now, what's the conceptual framework? Here I put up these pictures of the three gentleman that figured out the classical model of urban spatial structure, which is basically a simple model that's a circular city with all the jobs in the center and everybody commuting to the center. And with this model, they've been able to explain most of the things that we're talking about, and mainly expansion. What they're saying is, if more people come, the radius of the circle is going to grow. If there's more income in the city, the radius of the city is going to grow. If transport costs decline, as they have over the last 200 years, the city is going to grow. And the same with density. What happens to density? When income rises, density declines. Why does it decline? Because people have more money to buy more space. In Tianjin, for example, as Alain Berthaud has noted, at the time Deng Xiaoping got into power, people had 6.5 square meters per person. Now they have 25 square meters per person and more light and air. That takes space. Cities expand. Tianjin is expanding. So that's the theory. Now, we have, as Greg was saying, using satellite imagery, we've been able to measure 5 different aspects of urban spatial structure. The first one is urban land cover, simply the built-up area of cities. Here you see Beijing, built-up area, 1/11 of its municipal area. So you realize why before, when you try to measure density, for example, and you only had the administrative area, that's not a very good way to measure density. Population divided by administrative area is subject to a great error. When we divide it by the built-up area, we get a real measure. And that's what we do when we measure density. So density is simply population divided by the built-up area. And there's great variation in density both between cities and over time. When you see 2 American examples, you see Los Angeles, when the kind of lower middle class suburbanized with 1/8 of an acre plots in the 1940s, that was called sprawl. Now look at New Jersey sprawl in the 2000s. This is sprawl compared to Los Angeles, which is now, by the way, the densest American metropolitan area. The third one is centrality. Sorry, this kind of moved around. That simply is the traditional way that urban economists look at cities, which is a decline of density with distance from the city center, and that shows you the decline in Paris. Another thing that we looked at is fragmentation. I don't know why these highlights moved away. Fragmentation has to do, as Greg was telling us before, with the amount of open space within cities. And up in the Medina and Fez, no open space. In the Le Corbusier's Plan Voisin for Paris from the 1920s, high density, but a lot of open space. So what you have to understand is that the amount of open space and the density of the built-up area are 2 independent measures that have to be studied independently. Finally, compactness, which is something that I've done a lot of work on, has to do with the overall shape of the built-up area and the extent to which cities are circular. So what you see here in Chicago is in the 1940s, you see a lot more like a tentacle-like expansion, and by the 2000, it becomes much more of a half circle. So the compactness of Chicago is growing. Now, sources of data. As Greg was saying, we used new sources of data for this, 3 of which are satellite imagery. So we had taken some 4,000 cities that had 100,000 people or more and sampled 120 of them. And these are the black dots that you see on the screen. We also looked at, and for these, we got 2 satellite images, and we classified them into built-up areas. So what you see here, that's a built-up area in Cincinnati in 2 time periods. So we used another set of data, which is the U.S. data for 1910 to 2000, which is already online and is already digitized. So here you can see the development of the urbanized area of New York. Urbanized area is defined by the census as the census tracts that have more than 1,000 people per square mile. So this is what you see how New York developed, and we've studied 20 of these cities over the 20th century. Then we took 30 cities, and this was mostly the work of Alex, and we looked at maps of these cities, because maps, traditionally, historical maps, show the urban area of the city. So what you see here is a Paris map from 1834. You can see pretty clearly what's the built-up area of Paris. So Alex collected 250 maps of those kind for 30 cities to be able to create maps like the one for Paris and be able to measure what happened to density in these maps. By the way, all of this information, as Greg said, is now online at the, what we call the Atlas of Urban Expansion on the Institute's website. Finally, as Greg mentioned, we looked at the universe of 3,600 cities that had 100,000 people or more in the year 2000, and that's the map of these cities. And for these cities, we looked at another satellite image, which is a 500-meter pixel resolution, rather than the 30-meter pixel resolution which we investigated for the sample. So you see that this is not as fine as a resolution, but you can still see basically the same shape of Paris with a lower resolution satellite image. Okay, now what happened to densities? First, we see incredible differences in densities between cities. In the sample, Hong Kong had the highest density, had the second highest density, 530 persons per hectare. Dhaka, Bangladesh, had a higher density with lower-rise buildings. The lowest density was in Tacoma, 16 persons per hectare. The picture there is downtown Tacoma, right, compared with downtown Hong Kong. Now, what's the difference in density in the sample? Approximately, the density in developing countries is approximately double the density in Europe and Japan. And the density in Europe and Japan is approximately double the density in land-rich developed countries, by which we mean the US, Canada, and Australia. So that's the kind of rule, 1 at 4 to 1 for densities in general. The densities, when you look at maps of all countries, this is kind of the picture that you get. You get fairly high densities in China, lower in India, in Africa, a mix of high and medium densities, in Latin America, lower densities, and of course America and Australia and Canada, very low densities, and slightly higher densities in Europe. So in terms of density decline, now density decline, we discovered only we started investigating the data. And what we found is that in the global sample, density declined by 2% between 1990 and 2000. And that's what you see here, the two first columns. And they declined in the same rate in the three groups. They declined by 2% in developing countries, in Europe and Japan, and in the US, Australia, and Canada. Namely, density decline is a global phenomenon. Suburbanization and sprawl, if you want to call it, is a global phenomenon. This is what happens when you look at the sample as a whole. The straight line is if densities didn't change between 1990 and 2000, and you see that most of the points are below the line. And not only that, what you see here is that the densities in places that were very high densities are declining the fastest, which is good news. What happened in the U.S.? For some reason, this machine has discombobulated my presentation. It wasn't supposed to look like that. But the U.S., 20 cities in the U.S., and you see density decline in all of them. The last column is the average density decline. You see it decline every decade. And the decline was approximately between 1910 and 2000 was approximately a 5-fold decline. Now, what has happened in historical city, in the kind of last 200 years? So that decline in density that we saw in the U.S. is actually a global decline. We've seen that in all the cities that we investigated from 1800 to 2000. They reach a peak. Sometimes they reach the peak even before 1800, and then they start to decline. So these are two examples. Here's Cairo that reached the peak relatively late and then started to decline, or Algiers that reached the peak before 1800 and then started to decline. And what you see in Algiers is like a 9-fold decline. In Cairo, a 4-fold decline. But if you look at all of them together, you see that they all decline, except Los Angeles, it's relatively flat. We didn't have much to decline from to begin with. But we see that density decline has been universal and has been going on for a long time. So just to put it in perspective, we considered the high, when you look at projections, the high projection would be a 2% decline of density into the future. The 1% decline would be the medium projection, and then no decline, which is the situation in the U.S. today with Los Angeles and a few other cities that have stopped declining density. That would be the third assumption. So we made 3 assumptions about density decline given the study of densities. What happens to fragmentation? Fragmentation is basically, as Greg noted, is how much open space is included inside the built-up area. So we created 2 measures of open space. I don't want to go into the detail, but one of them is you take every built-up pixel and you draw a kilometer circle around it and measure how much open space there is within this kilometer circle. Other people have done that. That's called the openness index. The other one is what we call the city footprint, is you take the urban and suburban pixels and you draw 100-meter rings around them and all the open space that is within 100 meter of built-up area. That would be the city footprint. And then what we see here is that the minimum open space that is added in cities is in places like Los Angeles, mostly built up with a little bit of open space on the periphery. When you go to Chinese cities like Zhengzhou, the open space triples the area of the city. So here are the 2 indices. So in general, what we see that the openness index is roughly 0.5, namely half the areas of cities is open on average in the world. And it goes from between 30 and 40%, and it goes all the way up to 90%. And the same with the city footprint. The city footprint, if you add the open space to the built-up area, it doubles the area. So again, twice the area is the norm, and at least 1.4. So that at least adding 40% to the area. Now, when you look at special cases, and this again with acknowledgement to Alain, who gave me this picture, this is Tianjin. So what you see is they're taking urban villages where the majority of workers, they don't have hokus, they don't have residence permits, live. They're destroying them, and they're building apartment blocks which are not affordable by these workers. They're destroying affordable housing to build affordable housing. Right? That's what they do in China. So, and they try to preserve cultivated land. So what they do is they destroy the village where the people live, but the cultivated land remains in cultivation, which is what you see in this picture. This is why, or at least one of the reasons why, Chinese cities are more fragmented than other cities. And inside these cities, there are people who are engaged in subsistence agriculture. It's very romantic, but when you talk to them, You ask them, do you sell any of this? No, we just eat it. Why are you doing it? Well, we've always done farming. Why not do it some more? But basically, they're all landlords because they took their residential plots, the villagers, it is 200 square meters, and they built a 4-story apartment house there with 24 rooms, which they're renting to workers. So all of these urban villages, and you can look at it in detail when you look at Google Earth, you can see all of that. They are not engaged in farming. This is just what used to be called gentleman farming. This is the Chinese version of gentleman farming. Now, an interesting case is Portland, Oregon, like the prize urban containment example of the U.S. This is the urban growth boundary of Portland, and this is the built-up area and the urban footprint, the city footprint in 1973 and in 2005. So what you see is that Portland reduced its city footprint ratios substantially from 2.2 to 1.5. So they did a lot of infill. Now, the interesting thing is when you look at the density of the built-up area in Portland, has gone down. So people are still like the idea of living in a suburban home with a big garden, but they are within the urban growth boundary. So the idea of densification, one of the great goals of containment, at least in Portland, when you measure it on the built-up area, has not yet been attained, but we're working on it. Now let's talk about expansion. That's interesting because this is something that when we only study population, as Abba pointed out, we don't see it. Because we say, oh, the population is growing, the population. But when you look at expansion, you get a totally different picture. So here's Accra. And Accra increased its population by 1.5% between 1985 and 2000. But its area increased by double that. So what is happening is that the level of expansion is a lot faster than the level of population growth. So population growth is really not a very good indicator. It's a good predictor of expansion and not a very good indicator when you don't take into account the fact that densities are coming down. And that, again, to show you Bangkok, an interesting example. So you look at the map of Bangkok, you look at it in 1850, it was a little blob there, and then it starts to develop. And then, as I said before, it multiplies itself by 16 times from 1944. So between 1944 and 2000, Bangkok grew by 16 times. That is something that we have to address, because just the population growth of Bangkok is something that we just kind of raise our arms. Yeah, we can't prevent people from coming to Bangkok. All right. Now, what do you do with them? How you plan for them? That's a different matter. That's something that we can address. Now, we actually looked at urban land cover in all countries, and in general, when we look at the world as a whole and we measure very carefully, I measured total urban land cover in the world right now is of the order of 600,000 square kilometers. By the way, there are 10 different measurements of this. Some going as far as 6 times more. The people who do night lights, who are very wrong about how to do urban expansion, estimate that there's 3.5 million square kilometers of urban land in the world. There aren't. There are only 600,000, and it amounts to about 0.46% of the land area of countries. That's something to remember. Now, when you look at actual countries, of course, in Europe, cities take up more land than 0.5%, takes up more than 8% and more than 4% in some countries. And, of course, in Japan, it takes up a lot larger percentage. But in the U.S., it's still between 1% and 2% of urban land cover. This is to show you that the U.S. is definitely the largest consumer of urban land. It consumes more than twice the next country down the line, which is China. It's more than 100,000 square kilometers, about 1/6 of the world. But this urban land cover correlates quite strongly with GNP. Not GNP per capita, just gross GNP. The more GNP you have, the more urban land cover you have. Now let's look at the projections. Here are the projections, and I think Abba again mentioned that by 2030, the population of developing country cities will double. What you see is the land-rich developed countries in Europe and Japan, the population is stable. It's not going to move, right? It's not going to move. It's going to stay below 1 billion. The population growth is all going to happen in developing countries in different regions. Mostly we have in South and Central Asia. That's the most growth, and then we have Sub-Saharan Africa. And then less growth in Northern Africa, Western Asia, and Southeast Asia. So that's in terms of population. Now, what's going to happen to urban land cover? Now, here it's interesting. Now, urban land cover with the three assumptions. One assumption is no change in density. The other assumption is 1% decline in density. And the other assumption is 2% decline. So what you see, no decline, that's the lower area, then adding the blue and adding the red. Now, the interesting one is for the developing countries as a whole. Just by population growth, no change in density, we're going to see less than doubling of the urban land cover. But if we start taking density into account, we are going to see urban land cover grow up by a factor of 5, which is nothing compared to what will happen in Sub-Saharan Africa, where the expectation is that urban land cover by 2030 will be 5 times what it is in 2000, and by 2050 will be 12 times. So this is where we're going to see the most rapid expansion of urban land cover. Generally speaking, again, in developed countries, that's what we're going to see, and in developing countries, that's what we're going to see on average. So if no density change and full containment, everything is going to remain the same until 2050 in the developed countries. If densities continue to decline, then urban areas are going to triple or more than triple by 2050. Of course, in developing countries, we're going to see a tripling of the land area by 2030 and up to a 7 times increase in built-up area by 2050 under the most relaxed assumptions. Finally, I want to talk to you a little bit about what to do, which is what's the alternative to containment, because I think that containment is inappropriate in urbanizing countries. And the reason it is inappropriate is one of the idea is to densify. And the people who talk about densification, well, if they come from Tacoma or from Portland, it makes great sense to densify. If they come from Dharavi, it doesn't. This place has some areas in it which have 3,000 people per hectare. And in general, it has more than 1,000 people per hectare. Talking about densification in Mumbai is not realistic, and it's unreal. And like Weber, who was commenting on American cities in 1899, not Max Weber, but a statistician called Weber that wrote a book about urban America in 1899. He was saying, it is our hope that suburbanization will reduce the overcrowding in the slum areas of our cities, which he was right. That is what happened. So the Lower East Side for example, lost density from 1910 onwards, where it reached the maximum density of something like 1,500 people per hectare. It just kept going down as people suburbanized. And that is what should be happening in places like Dharavi or Mumbai in general. Now, the second idea is that containment, that's a very good idea for people who actually obey the law, like the people in Oregon. But it's not for people in San Salvador who don't obey the law. So it doesn't matter how you color your maps. You can color them green anytime you want, but that doesn't mean that they're not going to build there. And in fact, this great map of San Salvador, when we measured how much development took place after the creation of the map, the amount of new development in the protected green areas and in the seismic zones was double that in the urbanized area where they were supposed to develop. So that's another reason. The third reason is that if you have containment and it fails because you wanted to protect open space. You fail and you end up protecting no open space at all. So unless you do something to protect open space by just coloring maps and saying this is the boundary of the containment, you end up with no open space. And I think Greg mentioned before, Sao Paulo, the worst example of expansion without open space. This in 1,500 square kilometer area with no open space at all. Just construction, and no protection. The other thing is, if you don't plan for expansion, you end up with no arterial roads. Now, Bangkok is the best example of that, where the laissez-faire philosophy reigns supreme, and there's very little planning preparation for growth, even though this is one of the largest cities in the world. This is one of the suburbs that developed while we were living there, and what you see here is the road going north. This is Pahonyutin Road, and that's the Lat Phrao Road. And what you see is that there are 8 kilometers between the two roads that don't have an arterial road that can carry transport. As a result, Bangkok is one of the most congested roads, one of the most congested cities in the world. I mean, you can sit in traffic and look at the kind of a commercial outside the window of the car and talk to your friends, and half an hour later you look outside and the commercial is still there. I mean, you can still see it, right? So now, there have been very few examples that I found where there have been realistic projections of how much land is going to be needed for expansion. And that is a surprising thing. After all the data that I showed you about how cities expand, I found 2 historical examples which I like. One is the Commissioner's Plan of New York in 1811, where New York had 100,000 people, and the commissioners created the plan to house 10 times that population. Now, that's sensible planning. Of course, this was filled in quite rapidly. That's another matter. But at least they had 10 times the land that they prepared for expansion. Ildefons Cerdà in Barcelona did the same thing. This is a competition submission that he won, and then he spent 20 years actually putting it into practice. And when you look at the Google map of Barcelona, you see exactly that plan. And again, Barcelona, 150,000 people in the port, and he creates a plan for a 10-fold expansion of the city. These are the kind of plans that we need, and very unlikely to get. Now, what do we mean by realistic projections? I just talked to you about how much land we're going to need for expansion, given some minimal assumptions about density and about fragmentation, not even taking into account fragmentation. This is the multiple of urban land in different countries by 2050. So what you see that is, let's look at the 1% decline, right? The 1% decline there's going to be 30 countries that are going to have more than 4 times their urban land areas. There are going to be 50 countries with 3 times their urban land area. There are going to be 20 countries with more than 10 times their urban land area. This is under the 1% assumption. Under the 2% assumption, that's a much different story. We're going to see more than 40 countries that are going to increase their urban land cover by more than 10 times. Now, what do we need to do is the first thing we need to do is what I call realistic projections of urban land needs. That's what I just was talking to you about. The second, in light of the experience of São Paulo, we have to protect open space. And what I'm claiming is that the containment people are not protecting open space. They're just creating a recipe for failure. So what I'm talking about is selective protection of open space. You say, we want to protect this, we want to protect that, we want to make sure that there's a football field in every neighborhood, we want to make sure that there's a park here, we can protect that river, we can protect that wetland, and actually protect it. And plan your protection with the amount of resources that you have, both human resources and financial resources, to where you can really protect. So when you can name a certain open space after the grandmother of the mayor, and where you can get the NGOs to go there every weekend and plant trees and get their children to play there so that the developers don't come and the squatters don't come. That's how you protect open space. If you don't do something by just coloring maps in green, is not the way to protect open space. Now, Singapore, which is given here as an example, is a great protector of open space because that's all they have, and they have to protect their water supply, so they have to create to protect all the areas around their reservoir from construction, and they have an incredible system of open spaces, a hierarchy of open spaces of 7 different kinds that they have. They're an example to all of us. Of course, very difficult to emulate Singapore, but they deserve mention as a place that has created a proper hierarchy of protected open spaces. And finally, what we need in areas of expansion is an arterial grid, something that we don't have in Bangkok. And we need it at about 1 kilometer so that it can carry public transport. Now, it's interesting that some places have that grid. In the United States, for example, the Northwest Ordinance from the time of Jefferson actually surveyed the United States in 1-mile grids. And there are a lot of cities like Detroit or Omaha, even Los Angeles, which have arterial roads every mile. And as a result, are less congested than places like Atlanta, which were built before the Northwest Ordinance and don't have an arterial grid. Now, one of the best examples is Toronto. And this is actually not a road map. This is the bus map, the bus and streetcar map of Toronto. You just see that they basically have buses on an arterial grid, and they have one of the best public transport system in North America, the 3rd largest public transport system in North America. So finally, what is my suggestion for a paradigm for getting cities in urbanizing countries to prepare for their coming expansion? It's a relatively simple idea, and it's minimalist in the sense that I don't expect great guns from all of the planners and the decision makings in these places. So I'm trying to say let's demand and try to do the absolute minimum. And the absolute minimum boils down to 4 things. First, to have a realistic projection of urban land needs, right? No matter what assumptions you make, but be realistic about it. It's not just saying we don't want to grow is not a very good prediction of how much land you're going to need for expansion, which is the answer that you usually get when you come to a mayor and you say, well, we think your city's going to grow. He says, we don't want to grow. We don't have a budget. Yeah, but it'll grow. Okay. So first is a realistic projection of urban land needs. Second, the institutional requirement there is to create generous metropolitan boundaries, namely to expand. And I hope that Eduardo will talk a little bit about that. That's not an easy thing to do institutionally, but expand the area that is needed for metropolitan growth. In a way, it's the same as the urban growth boundary of Portland. It's just more generous with how much land is going to be needed for expansion. The third is the selective protection of open space, which I already mentioned. And that is, you have to decide what you want to protect and protect it rather than think that you're going to protect everything. And fourth, that in areas of expansion, you have to create an arterial grid. Now, what I mean by create it, again, is not just put it on the map, but get the rights of way for these roads right now. And together with one of my colleagues, Ralph Gackenheimer, who's sitting here today, we had a project supported by Billy Corbett from Cities Alliance, and it was a World Bank project. We had a project to go and look at urban expansion in 7 intermediate cities in Ecuador, where we brought the municipal teams to a one-week workshop in Quito 2 or 3 years ago, and they planned the expansion and the cost that it would take to get the right of way, either because the law says that it's automatically there, which Ecuadorian law does say, that when you turn your land from rural to urban, you can take 35% of the land for public use. And they did this exercise, and they calculated that for $1.5 million, each one of these cities could have a system where they would have acquired the right of way for the expansion of their cities in the next 30 years. Now, this grand project was canceled when the president of Ecuador declared the World Bank representative in the country persona non grata and kicked him out because he doesn't like the World Bank. So much for that. So much for the case study in urban expansion that Billy and I were hoping with Ralph to get on the books. But we hope to get this thing going soon, maybe if not in Ecuador, then somewhere else. Thank you very much for coming and listening.